So section 6.6 is all about identifying quadrilaterals based on information that you're given. So really it's nothing new. We're just taking everything we've talked about for all of our quadrilaterals and putting it all together at once. Anybody need more time with the objective? Okay. For our warm-up, name the figure described. A quadrilateral that is both a rhombus and a rectangle. A square is both a rhombus and a rectangle. A quadrilateral with both pairs of opposite sides parallel. A parallelogram. So if we don't know anything other than that, the most specific that we can be would be to say parallelogram, which I did not give myself enough room to write. That is going to be true about special types of parallelograms. Like, for example, it would be true about a square. However, if we don't know any of the defining features of a square, we can't call it that. So parallelogram is as specific as we can be. A quadrilateral with exactly one pair of parallel sides is a trapezoid, only one pair of parallel sides. Remember, trapezoids are not parallelograms. Any parallelogram with perpendicular diagonals is a rhombus. Rhombus was when we had perpendicular diagonals, which of course would be true about a square, but we don't know for sure that it fits all the criteria of a square. So this is basically our goal for today, is just to be able to decide what type of parallelogram or what type of quadrilateral we have. Anybody need more time on those warm-ups? Okay, so there is a little bit of writing involved for you today. So I will put these up here, give you a minute to write, and then we'll talk about them. We'll probably go through these pretty quickly because, again, this is not new. We have talked about this stuff before. All right, if we want to show that a quadrilateral is a parallelogram, we need to know one of the following to be true. This should be the list that you're most familiar with, is the parallelogram list. We started on this all the way back in section 6.2 and 6.3. So by the definition, both pairs of opposite sides are parallel. That makes it a parallelogram. But you know that it's a parallelogram if you have opposite sides congruent, if you have opposite angles congruent, if the diagonals bisect each other, or that last one is one that we haven't really talked about yet. If you have a pair of opposite sides that is both parallel and congruent. So if that one comes up, you would also know that you have a parallelogram. Now, the one that's not really listed there is about the consecutive angles, because it kind of goes back to your opposite sides being parallel. What would need to be true about consecutive angles? Consecutive angles have to be supplementary, but that goes back to being able to say that opposite sides are parallel. Okay, because if you know that you have consecutive angles supplementary, you could show that your lines are parallel to each other. Anybody need more time on the parallelogram slide? Okay, on we go. Maybe. So we've got showing that a parallelogram is a rhombus. So notice that we have to already know that it's a parallelogram on these. So if you already know it's a parallelogram, these are the ways you could prove that you have a rhombus or a rectangle. Bless you. All right, so if it's going to be a rhombus, It first has to be a parallelogram. All four sides need to be congruent. The diagonals are perpendicular to each other. Does anybody else remember the other thing that's true about the diagonals for a rhombus? They're not necessarily congruent. They do something to the angles. They bisect the angles. So diagonals in a rhombus are going to bisect the angles. Sometimes they're called vertex angles, or those angles that are in the corners. Something else that the diagonals will do in a rhombus. If a parallelogram is going to be a rectangle, we need to have all four right angles. And in a rectangle, the diagonals are congruent to each other. To have a square, you either need to have a rectangle with four congruent sides, which would mean it's got all right angles and all sides congruent. A rhombus with four right angles, which would mean all congruent sides and all right angles. Or you could know that the diagonals are both perpendicular and congruent. So I summed it up at the bottom. A square is a rhombus and a rectangle at the same time. So you have to know that it is both a rhombus and a rectangle at the same time. Showing a quadrilateral as a trapezoid is pretty easy. You need to show that one pair of opposite sides are parallel. That's it. Just one pair of them. You can do that usually using your consecutive interior angles. Consecutive interior angles should be what if lines are parallel? Not congruent. Supplementary. So consecutive interior angles would be supplementary, or they could just be marked with the little parallel triangles. Anybody need more time on the trapezoid slide? Okay, so let's go through some scenarios here. We are told that ABCD is a quadrilateral, so it's got four sides. We are asked to give the most specific name based on these criteria. Now, every time we switch to a new line, A, B, C, D, E, F, we start over. So it's kind of like a fresh set of rules each time. Does that make sense? We're not building on each other. Each one is its own problem. So we know we have a quadrilateral. We could draw them. I'm going to take this away so I've got a little space to draw quadrilaterals. And we could label what we know if that helps. Now, when I draw it, it's going to probably look like a rectangle or something, but I don't really know that for sure. But if this is my A, B, C, D, we are told that A, B, and C, D are what for this first one? Parallel. So I could mark that. Those are parallel. And I'm told that they are also congruent or equal to each other, so I can also give them each a tick mark. So those are opposite sides that are both parallel and congruent. So that would make this a I don't think it's a rectangle. Parallelogram. That was number 5 from our parallelogram list on the front. An opposite pair of opposite sides that were both parallel and congruent. Do you remember that? Or we can flip it over and look at it. So that would make this a parallelogram. We don't really know anything further about it, so we cannot classify it any better than that. Okay, on letter B, it's kind of like we're taking away... Ooh, that's not what I wanted to do. Well, we'll just start fresh with a new one. So letter B, we're taking away what we thought we knew on the first one. Is that somebody at our door? And we are instead talking about AC and BD. Diagonals. So we know that the diagonals bisect each other. And we also know that the diagonals are congruent. So if the diagonals bisect each other and the diagonals are congruent, what do we think? So if the diagonals bisect each other, it's definitely a parallelogram. But if they're also congruent to each other, that would take it one step further and make it a rectangle. So on letter B, which I've got no great place to write it, so I'll put it up here. This would be a rectangle. Okay, the first part of it made it a parallelogram, but if you know that you have a parallelogram and the diagonals are congruent, that makes it a rectangle. All right, on letter C, we're again looking at our diagonals. So we know that we've got diagonals that are perpendicular to each other and they bisect each other. Why is it a rhombus and not a square? What do we not know about it? Good. We don't know that the diagonals are congruent to each other. So we know that they're perpendicular and they bisect each other. Bisecting each other makes it a parallelogram. Perpendicular to each other makes it a rhombus. But we don't know that they're necessarily congruent to each other because, remember, we kind of leave out what we knew from the step before. So a rhombus is as specific as we can get on letter C. What about letter D, where all we know So on the front, I know some people want to say rhombus, but for a rhombus, we were proving that a parallelogram is a rhombus. Does that make sense? So does this tell us that I necessarily have a parallelogram? No, nothing about perpendicular diagonals tells me that I for sure have a parallelogram. Do we see the difference between C and D? Okay, so if I don't even know that this is a parallelogram, does having perpendicular diagonals do anything for me? No. So really, we can only call this a quadrilateral. I understand why a rhombus is tempting, but if they don't tell us that it's definitely a parallelogram first, we don't really know that we could call it a rhombus. All right, letter E. We know that AB, BC, CD, and DA are all congruent to each other. That would be a rhombus. So if we have opposite sides congruent, we know it's a parallelogram. So if they're all congruent, opposite ones are congruent. So it's definitely a parallelogram, and if all four sides are the same, I would agree that it must be a rhombus. All right, last one on this slide. AC and BD bisect each other. So again, AC and BD are the diagonals, so we definitely have what? If the diagonals bisect each other, it's definitely at least a parallelogram. If we have diagonals bisecting each other, it's at least a parallelogram, and then we can build on it from there. Are we all understanding what I mean by that? Okay, it's at least a parallelogram. AC and BD are perpendicular. So that would be, again, the diagonals are perpendicular. We also know that AD and BA are perpendicular. So let's just, if we've got diagonals bisecting each other, it's a parallelogram. If diagonals are then also perpendicular, then it is a rhombus. But then we also know that we've got right angle occurring between AD and BA, which would be up in the corner here, which makes it also a rectangle. So if it is both a rhombus and a rectangle, we know that it is a square. We all following the logic there? Questions, concerns, need more time on this slide? Okay. Last up, must these be a parallelogram? Explain. What do we think on the first one? Why not?
Because the opposite angles are congruent.
Okay, so no, opposite angles are not marked congruent. What about the last one?
Yes.
Why?
The opposite sides.
What kind of sides are parallel?
Opposite.
Good. Both pairs of opposite sides are parallel.